All right, now we're going to get to a theorem that might sound a little bit wordy, but once I highlight some words that demonstrate the actual meaning of it, it'll make sense. The measure of an angle formed by two chords, there's a chord, that intersects inside a circle, the measure of the angle inside the circle, is half the sum of the measures of the intercepted arcs. Okay, so here's what's going on. If I am inside a circle, then it's going to be half the sum. And those are the key words that's going to help us out. So you'll see what I mean as I keep writing. Let's see, AB is 22. This arc is 22 degrees. Now what that really means is if I was to connect A to F and B to F, then this angle BFA would be 22 degrees. All right, DC is 48. And then find the measure of angle DEC, and CEB. We'll tackle CEB later. Let's find DEC first. That's a little angle right here. We're going to call it X degrees. So if I'm dealing with something inside a circle, and I have the two chords, it's going to be half the sum. So take half of the sum of those. It's really the average. So X is half the sum, 22 plus 48, and it's really going to be that easy. So X equals, well, half of what you get when you add those together. You add those together and you're going to get 70. Yeah, you're going to get 70, and so that would be 35. So X is 35, and that means that X is a DEC is a 35-degree angle. So angle DEC is 35 degrees. And while we're at it, we'll find CEB, and this one's going to be pretty straightforward, and we don't have to use any of the skills we just learned. If this angle is 35, then all I have to do is do 180 minus 35, and it will tell me this one. Because, you know, straight lines make 180 degrees, right? So 180 minus 35 is going to give me this one right here. I'm not even going to give it a variable. So this little guy right here, I'll give it 2 swooshes so it doesn't get marked as congruent to that. By the way, if you put like a swoosh in an angle and a swoosh in another angle, that means they're the same. For example, this and this are congruent to each other, right? This one has 2 swooshes, so it's not going to be the same as that one. So let's see, 180 minus 35 is 145. So there we go. So angle CEB is 145 degrees. Okay, next problem. Angle AED is 129. AED, 129 right here. Which, if you want to go crazy on it, that's also 129 down here. DA is 112. The arc DA, so this is 112. And find the arc CB. It is a minor arc. If it was a major arc, they would have given us a third letter, and that third letter would have wound us around more than half the circle. Okay, so what I have here is, again, two chords that intersect inside a circle, and I'm half the sum. So 129 is 1/2. Let's just go ahead and write it. 129 is 1/2 of this arc plus this arc, and that's what they're asking for. We don't know what that is. So what's the degree measurement? We don't know. And that degree measurement would be if I connected B to F, F to C, and we have an angle here that looks like it'd be almost a diameter. So it's going to be pretty big. So let's figure out what this is. We'll just use our skills on this. Let's double it first of all. If I double this side, and I'm going to show a little bit too much work, but if I multiply by 2 and then I multiply by 2, then I cancel those. And we're going to have 112 plus x, and that's equal to 129 times 2, which is 258. And then we're going to subtract 112 from both sides. And that means that x is 146. And so this is a 146 degree